about focus, Directrix, conic section definitions. Alright, PF over PD is equal to epsilon, or E, whatever you want to call it. What does that mean? Well, let's take one of our favorite conic sections, the parabola. Let capital F be a focus, let P be an arbitrary point on the conic section, and let D, for Directrix, be the point at which touches the Directrix. Notice in the parabola's case, D1 is equal to D2. And we can say that D1 is called PF, from P to F, distance from P to F. And D2 is called PD, like distance from P to D. Notice that in the parabola, this was defined to be the same. D1 is equal to D2. So notice that the ratio of D1 over D2 is going to be equal to 1 if they're the same. If D1 is equal to D2, then D1 over D2 should equal 1. Notice that precisely D1 all over D2 is a PF divided by PD, which is equal to epsilon. Oh, take a look. Oh, take a look. Everything is the same and it's equal to 1. So notice that in the case of the parabola, E or epsilon being equal to 1 gives you a parabola. In the other cases in which such a ratio is greater than 1, higher, you get a hyperbola, and when it's lower, you get an ellipse. So, after that, let's talk about the two various forms that you can get, the standard forms for polar equations of conics. They're in polar. So they're going to be associated r comma theta, and in this case, r of theta function, which is going to be EP divided by 1 plus or minus E plus or minus E cosine of theta, or r of theta is going to be equal to EP divided by 1 plus or minus E sine of theta. These two will cause various shapes. Okay? Various conic sections are associated to these right here. And there's a method to knowing it by memorization, and there's a method to knowing it by just doing an r of theta theta table. I never encourage memorization. However, as a student, when you're in a timed test, in a timed scenario, memorizing such things might be slightly practical and necessary to perform well on the test to answer the questions quickly. So whenever we have plus cosine, r is equal to EP divided by 1 plus cosine of theta, we get a shape like this. Alright? The conic section will open up like that. It doesn't always mean you have a parabola. These rules tell you what kind of conic section you have, but at least that tells you that that opens up like that. And when r is equal to EP all over 1 minus cosine of theta, you get this. Oh, I mixed it up. It's just the opposite side right here. This gives us that. This gives us this here. So notice positive cosine open to the left, negative cosine open to the right. It's still on the x-axis. Here, I'll do the negative cosines. Now it's going to be opening up on the y-axis. And so opening up, we have the negative sign. So this will be r is equal to EP divided by 1 minus sine. There's an E there. 1 minus E sine of theta. And over here we got r is equal to EP divided by 1 plus E sine of theta. Okay? P is your regular old, where is the Directorix? So here, x is at negative P, x is at positive P, y is at negative P, y is at positive p. And what is e? It's the same e as this right here. It's the same e we've been using all along. So let's solve a problem here. Let's solve an example problem, all right, and figure out how it could kind of give us an idea of what kind of graph we have. What if we have r is equal to 4 divided by 2 plus cosine of theta? Okay? Notice that this is not in standard form. Standard form would be r is equal to ep divided by 1 plus e cosine of theta. So in order to get into standard form, this 2 must turn into 1. To do so, we must factor out a 2. Notice that this causes cancellation in the numerator and the denominator, so I get 2 divided by 1 plus 1/2 cosine of theta. So now, 2 is equal to EP, and I know E is 1/2, which says that 2 is equal to 1/2 times P, multiply both sides by 2. This implies that P is equal to 4. And you're done. P tells you about where the Directrix is. You got a Directrix with an ellipse, you got a Directrix with a hyperbola, you got a Directrix with a parabola. But this E tells you what kind of shape is it. E is equal to 1/2. That's less than 1. That means you get an ellipse. So whenever you graph such a shape, you should get an ellipse. Let's do another example. Let's do r is equal to 12 divided by 3 plus 3 sine theta. Okay, that is what we're given. What is it in standard form? EP divided by 1 plus E sine theta. We don't have a 1 here. We need it to be a 1. What do we got to do? We factor out a 3 at each term here. 3 here, and 12 is really 2 times 6, which is equal to 2 times 2 times 3. The 3's cancel, so I get 4 in the numerator. So I get 4 divided by 1 plus sine of theta. EP is then equal to 4, and the E is equal to 1. So that means P must also equal 4. So what kind of shape do we have? Well, E is equal to 1. We got a parabola. Its Directrix. Well, its Directrix is located at P, and its focus is going to be located at P. And you'll notice that it's a parabola, and the way it opens is the way the general form shows. It's something that looks like this. Alright? So, that was a quick rundown of conic sections and their general forms.